Hello, so this is question 12 of the revised GRE general test. Uh, the question here is it's a set problem. It says in a graduating class of 236 students, 142 took algebra, 121 took chemistry. Then you're told to find the greatest possible number of students that would have taken both algebra and chemistry. Alright, now in this question here, I'm going to let algebra, so I'm going to let A to represent the number of students that to represent the algebra students, and I'm going to let C, so I'm going to let C to represent the chemistry students. So alright, from the information we are given, it says in a graduating class of 236 students, so that implies that the cardinality of the universal set, so the cardinality of the universal set is going to be 236. Now I'm also told that 142 of the students, they took algebra, so that implies that the number of students that took algebra is 142. I'm also told that the number of students that took chemistry is 121. So the number of students that took chemistry is 121. Now I'm told to find the greatest possible number of students that could have taken both algebra and chemistry. So how do we represent that? So algebra and chemistry is the intersection of algebra and chemistry. So that is A intersection C. So what I want to find is the number of students that took algebra and chemistry. So this is what I want to find. So since I do not know the number of students that took algebra and chemistry, I'm just going to go ahead and then just call that, I'm going to call that X. So I'll call that X. Alright, so let's go ahead and solve this problem. Now the best way to solve this kind of problem is to draw a Venn diagram. So the Venn diagram, I'm going to represent the universal set with a rectangle. So this is my universal set. So you have this. You have something like this. Now the universal set, the cardinality is 236. Now I'm going to represent the elements, that is the subsets of the universal set, with oval circles. So A is 142. So this is going to represent my A. So this is my A, while C is also going to be represented by an oval circle. Now keep in mind that we're going to assume that there is an intersection between A and C. So this is going to be for C. So this is what we have. Now before you begin to fill in the circle, the very first place you want to start filling in the whole Venn diagram is the intersection of the whole oval circles, the intersection of all of them. So this is the area I need to start filling. Now according to what I have here, A intersection C, that is the intersection of the two oval circles, we assume it's equal to X. So that was our assumption, that it's equal to X. So this is equal to X. Now, so let's go ahead. According to the information we have here, it says the cardinality of the number of students that took algebra, that is the cardinality of A, equals 142. So intuitively you could think about that as the area of this whole circle here, the area of the whole circle here is 142. So since we have assumed that the area of this part here is X, then the area of the remaining part, that is the area of this remaining part, is just going to be 142 minus X. So again, the area of A is 142. That is the area of this whole thing here. So the area of this whole place here is 142. But then we have assumed that part of the area that is here, which is part of it, is X. So if the whole of this is 142 and then part of it is X, then the area of the remaining part is going to be the deduction of X from 142. Alright, so the same principle is going to apply to the next oval circle. So what you have here is C. You want to find the area of this part here. So what I have here is the area of C is 121. That is the area of this whole place. So let's use a different circle, different color. So the area of this whole place here is C. So, and then we know that part of it here is X. So that implies that the remaining part is going to be 121 minus X. Yep. So let's go ahead and find X. So the best way to reason this whole thing out is that since the area of the whole figure, which is 236, then that implies that when you add each of them, you're going to add 1, you add 2, and then when you add 3, 1 plus 2 plus 3, that is the area of the trio, should give you 236. So that's exactly what I'm going to do right now. So what I have here is 142 minus x, now plus, then here is x, then plus, then the next one that we have there is 121 minus x. So this is going to give us 236. So let's go ahead and simplify. So what you have here is 142 minus 121, then negative x crosses this, so what you're left with is negative x equals 236. So 142, okay, this is plus, so 142 plus 121 is going to give you 263. Negative x equals 236. So to find x, so x is just simply 263 minus 236, and that's going to give you 27. So this is your answer. So that is, here is going to be 27. So that's the intersection of A and C. So our answer is 27, and that completes the problem. Thanks for watching.